Hello guys, welcome back. Dr. K here again. Do you know what happens to an electron when it travels inside a uniform magnetic field? Do you know what's going to happen to the electron? Let's look at that problem now. So look at this. Here I have a uniform magnetic field. This is how we represent a uniform magnetic field that is into the page. So the field is going into the page. It's moving away from us into the page and it's uniform. Okay, so let's assume that there's a magnetic field like that. And then this is an electron. The charge is E, that's the electron, and it travels in this direction with a speed v. What do you think will happen to the electron? Is it just gonna go straight without any deviation, or is it gonna like move like that in a counterclockwise direction, or is it gonna move in a clockwise direction? What do you think? Is it this path the electron is going to take? Is it this path? Or is it this path? Let's look at that situation mathematically. Okay, so I'm going to draw the electron here. That's our electron. It has a charge E. And let's say that the magnetic field is in this direction. Okay, magnetic field is usually represented by B. And then the velocity vector, it's like this, V. And can you see the magnetic field vector is into the page, but the velocity vector is left to right. Into the page, the B field, velocity vector left to right. What do you think the angle between those two vectors? What is the angle? It's 90 degrees. That's right. It's going to be 90 degrees. So that's 90 degrees. Okay. Now, what happens is when an electron, when a charged particle is moving relative to a magnetic field inside that magnetic field, there's going to be a force acting on it. That's what we call the magnetic force. So whenever a charged particle is traveling inside a magnetic field, simply because it's moving, it has a velocity, there's a magnetic force acting on the charged particle. So how do we find that magnetic force? We have an equation for that. Okay, so I'm going to write down that equation. The force due to magnetic field, usually written as FB, is equal to the charge of the particle, usually given as Q. Then we have the magnetic field, the size of the magnetic field B, and then velocity vector, the size of the velocity vector V, and then the sine of the angle, that theta is the angle between the magnetic field vector and the velocity vector. So that's how we find the size of the magnetic force. But you know that the force is a vector quantity. So then how do we find the direction? That's where we are going to use our right hand rule. Okay, we are going to use our right hand rule. Just align your fingers in the direction of the velocity vector and then turn those fingers towards the magnetic field. Okay, it's like this. Turn towards the magnetic field and then look at the direction of your thumb. The thumb is pointing in a perpendicular direction to the plane where you have the velocity vector and the magnetic field vector. So V and B are on one plane, but the force vector is in a perpendicular direction to that plane. So if you use your right hand rule, you will see the force vector is pointing upward. However, that is for a positive charge. So this direction applies for a positive charge. But since the electron is negatively charged, the direction of the force is like that. So that's the direction of the force, magnetic force acting on the electron. And the size of that force is, I can simply replace Q by E, magnetic field vector size of that, velocity vector size of that is V, and sine theta, you can see it's 90 degrees, so sine 90. Sine 90 is just 1, so then the size of the magnetic field, magnetic force is simply EBV, and its direction is pointing downward. So if we go back to our original problem, so when the electron enters the magnetic field, let's say somewhere over here, so when it enters the magnetic field, there's going to be a force downward, okay? Because of that, it's going to move in this direction. And then when it comes to this point, you can see the velocity is in like that. That's the velocity vector, okay? The force is like that. That's the force. So you can see a velocity vector and the force vector, just like over here, they are perpendicular to one another. Okay, again a 90-degree angle. This is like a three-dimensional vector plot. These vectors are three-dimensional. Okay, so then what's going to happen is that the electron is going to do circular motion. It's going to go in a circular path with a constant speed. So the actual path for the electron is in a clockwise sense. It's going to move in a clockwise sense. Okay, so it's not this direction, it's not this one, but it's this one. The electron is going to go like that, and it's doing circular motion. Okay, so I hope you learned something important about magnetic fields, electric charges, and magnetic forces. Okay, so follow me for more important videos in physics and math like this. See you next time. Bye for now.